In our next lecture, we're going to look at how to define a rotation matrix. But before we get there, it would be useful to see how the dot product works. So imagine we have a vector v and a direction given by the unit vector u. If we look at the projection of v in the direction of u, the result would be this length over here. And based on the geometry of the sketch, if we know that this angle is theta, we can see that the result of projecting v in the direction of u will be the length of v cos theta. Now it would be useful if we could relate the coordinates of v and the coordinates of u to this calculation. So let me separate that out into a new sketch. There's v, there's u, and v has coordinates xv, yv. U has coordinates xu, yu. And we already know that the angle between these two vectors is given by theta. But with respect to the x-axis, we can also say that vector v lies at an angle of alpha v, and vector u lies at an angle of alpha u. And that immediately gives us a relationship between theta and the two alphas. So we see that the angle theta is alpha v minus alpha u. It also tells us something about the x and the y coordinates. We see that v, which is xv, yv, can also be written as v cos alpha v, v sine alpha v, and similarly for the unit vector, we can write xu and yu as the length, which is 1 times cos alpha u, and the length 1 times sine alpha u. Alright, so let's see if we can combine what we know from here into the calculation of our projection v cos theta. So we'll rewrite v cos theta as v cos alpha v minus alpha u. And we know from our trigonometric identities that this is equal to v times cos alpha v cos alpha u plus sine alpha v sine alpha u. If we want to simplify this expression, we go back to the coordinates we calculated over here, and we see that v cos alpha v is nothing other than xv, and v sine alpha v is nothing other than yv. We also know that cos alpha u is equal to xu, and we know that sine alpha u is equal to yu. So, here we have a very compact and elegant way of computing the projection of the vector v onto u by simply taking the product of the x's and adding it to the product of the y's. We can write this in vector format, so if we write that's v, we write v as the vector xv, yv, and we write the unit vector u as xu, yu, then we can write the projection of v onto u as v transpose u, which gives you this expression again. In general, we define this operator as the dot product. So for any arbitrary vector a and b, for any arbitrary vectors a and b, we define the dot product a dot b as a b cos theta, where theta is the angle between them, a is the magnitude of the vector a, b is the magnitude of the vector b.